This might sound strange, but the world's largest lithium battery company is quietly turning its back on lithium. CATL, the undisputed king of lithium-ion batteries, is betting big on something far more common: salt. That's right, sodium-ion batteries. Once seen as a scientific side project, they are now poised to shake up the energy world. Why would a lithium titan pivot to a less powerful alternative? What do they know that we don't? This story isn't just about chemistry, it's about geopolitics, cost, safety, and the surprising future of clean energy. Let's dive into why lithium's reign may be running out of charge. CATL, the global heavyweight of lithium batteries, is making a surprising pivot. Known for powering nearly half of the world's electric vehicle batteries, this Chinese giant has built its empire on lithium-ion tech. But now, it's pouring serious effort and money into a different element: sodium. In late 2024, CATL's co-founder Robin Zeng made headlines by challenging the industry's faith in solid-state batteries. Instead of following that trend, he placed his bets on sodium-ion, an older but re-emerging technology that might reshape the energy storage game. This isn't a casual experiment. CATL already includes sodium cells in its CATL battery pack, a hybrid system that combines the strengths of both lithium and sodium. The goal? To extend range while keeping costs down, especially in vehicles and large-scale grid storage where every dollar and degree matters. And there's more coming. CATL plans to roll out a next-generation sodium battery with an improved energy density of 200 watt-hours per kilogram. That's still below top-tier lithium cells, but it's a meaningful step forward from older sodium designs. So why take the risk? Simple. Sodium is cheap, stable in freezing temperatures, and easier to source. CATL seems to believe that as lithium prices fluctuate and global supply chains tighten, sodium might offer a safer, scalable alternative. So why take the risk? Simple. Sodium is cheap, stable in freezing temperatures, and easier to source. They aren't abandoning lithium, but they are clearly hedging their future. At first glance, lithium and sodium might seem like unlikely competitors. Lithium has long been the gold standard: lightweight, energy-dense, and deeply embedded in everything from smartphones to Teslas. But sodium is starting to catch up, and when you break down the science, the shift begins to make sense. Both elements sit in the same column of the periodic table, which means they behave in similar ways inside a battery. Like lithium-ion batteries, sodium-ion versions rely on the movement of ions between electrodes to store and release energy. Structurally, the two systems are nearly identical, but there's a key trade-off: energy density. Lithium still packs more punch per kilogram. That's why most EVs and high-performance devices stick with it. Sodium, on the other hand, tends to be heavier and bulkier, which limits its range and storage capacity in mobile applications. Beyond cost, sodium is more forgiving. It's less reactive, making it safer in high heat conditions and less likely to catch fire. It also holds up better in freezing temperatures, something lithium batteries notoriously struggle with. So while lithium still leads on raw power, sodium might win on price, safety, and resilience. And in a world chasing scalable, sustainable energy solutions, those qualities matter more than ever. Sodium-ion batteries aren't just a concept anymore. They're being tested in the real world, and surprisingly, even in electric vehicles. Despite having lower energy density than lithium, sodium is finding its way into EVs, especially through hybrid battery systems. The real kicker? Performance in the cold. While lithium batteries struggle when temperatures dip below -20 degrees Celsius, CATL claims its latest sodium cells stay functional all the way down to -40 degrees Celsius. That makes a huge difference in regions with harsh winters where battery reliability can make or break an EV. Still, the biggest opportunity for sodium might not be on the road, it's in stationary storage. Whether it's solar farms, wind power stations, or emergency backup grids, these setups don't need compact batteries. They need solutions that are cheap, safe, and easy to scale. CATL may have led the charge, but it's not running solo. Its main competitor BYD is moving aggressively into the sodium-ion space, and they're thinking big. The company is building a massive new factory expected to begin production by 2027. Once operational, it could pump out 30 gigawatt-hours of sodium-ion batteries annually. Why invest so heavily? Simple cost advantage. BYD expects sodium batteries to match the price of current lithium iron phosphate cells by 2025. And with further refinement, they believe costs could fall even more, by as much as 70%. That's a massive potential saving for a company producing everything from electric vehicles to home energy systems. BYD isn't waiting around to test their theory. They've already launched the MC Cube, a utility-grade sodium-ion energy storage system delivering over 1 megawatt of power and storing 2.3 megawatt-hours. While it trails some lithium-based systems in capacity, it scores in affordability and safety, and it's not just BYD. Companies like Jiangsu Hina Battery Technology are expanding fast, already in production and aiming for exponential growth across China. While China leads the charge in sodium-ion development, the United States is quietly building momentum of its own. At the forefront is California-based Natron Energy, a company racing ahead with bold claims and big infrastructure. Natron's edge lies in performance. Their sodium-ion batteries are said to charge and discharge up to 10 times faster than lithium-ion ones, and endure an astonishing 50,000 full cycles. That kind of lifespan is a dream for critical sectors like telecom and data centers, where downtime can be devastating. But there's a trade-off: energy density. Natron hasn't shared official figures, but third-party estimates put it around 70 watt-hours per kilogram, which is far too low for EVs. Great for stationary storage, not ideal for mobility. Still, the company is scaling up. It already operates a factory in Michigan and is building a massive 24/7 gigafactory in North Carolina. That's not a promise. It's construction in progress. Meanwhile, at the DECA lab, researchers are experimenting with TAC, a fully organic cathode made from common elements. Early tests show impressive conductivity and potential to boost sodium's performance. Backed by Lamborghini, this innovation could redefine what sodium batteries can do, not with rare metals but with smart molecules. Not every sodium story is a success. Enter Northvolt, a Swedish battery startup that once promised to challenge the giants. In late 2023, the company unveiled a sodium-ion battery with a respectable 160 watt-hours per kilogram. Not revolutionary, but solid. But just a year later, things took a turn. In November 2024, Northvolt filed for Chapter 11 bankruptcy in the US. That doesn't mean they're shutting down. Chapter 11 allows for restructuring, but it sent shockwaves through the industry. The company claims its European operations are stable and that its American subsidiaries remain funded. Still, it's a stark reminder: scaling battery tech is expensive, risky, and brutally competitive. Even promising technologies can falter if the business side doesn't hold up. In the battery race, science isn't the only thing that needs to work. So does the math. Sodium-ion batteries are generating buzz, but they still face serious challenges, especially in the electric vehicle space. The main hurdle: energy density. Sodium batteries store less energy per kilogram, making them heavier and less efficient for long-range travel. That's a big issue for EVs, where weight and space matter. Then there's the economic side. Sodium gained momentum during lithium's price surge, but with lithium costs now down over 70% in just 3 years, sodium's affordability advantage has narrowed. Manufacturing scale is another problem. Lithium has decades of infrastructure behind it. Sodium doesn't, yet. That creates a loop. Prices can't drop without mass adoption, but mass adoption won't happen until prices drop. A 2025 Stanford study raised doubts about whether sodium batteries can ever match lithium's cost at scale. So while the promise is real, turning that promise into widespread reality won't be easy. It'll take more than good chemistry. It'll take serious strategy and industrial willpower. Sodium-ion batteries aren't just a concept anymore, they're real and scaling fast. From CATL to BYD to Natron, major players are building factories and shipping products, betting big on a material as common as table salt. For grid storage, sodium's strengths are already clear. For EVs, the road is tougher, but progress is steady. It's not about replacing lithium overnight, but offering a safer, cheaper, and more sustainable alternative. That alone makes it worth watching. What's your take? Is sodium the next big thing, or just a backup plan? Let me know in the comments. Stay curious, and I'll see you in the next one. See you.